Welcome to the deep dive. Today, we're jumping into something lots of RC folks deal with, maybe without thinking too much about it, connecting batteries with mismatched plugs.
Yeah, specifically that Tamiya Dean's charging adapter for, say, your 7.2-volt nickel metal hydride packs.
Right. And our mission today is really to unpack why this seemingly easy fix, this little adapter, can actually cause some, well, pretty significant problems. Think electrical inefficiency, even safety risks.
We've dug through quite a few articles, some tech notes, research.
Lots of source material to guide us, so let's dive in.
Okay, so the sort of executive summary, if you like, from everything we looked at, using that Tamiya Dean's adapter, well, it works, functionally speaking,
Right.
but it's fundamentally compromised. It is really not recommended. Certainly not for regular use or leaving it unattended. Absolutely not.
Why not? What are the core issues?
You're looking at increased electrical resistance, first off. Then there's the risk of inaccurate charging, which can damage your batteries. Heat generation, sometimes a lot of heat. And honestly, the quality on these adapters can be all over the place.
Okay, that's a pretty strong warning. I bet a lot of listeners, myself included probably, have used these adapters thinking they're fine. So let's peel back the layers. It really boils down to the connectors themselves, doesn't it?
Exactly. It's a tale of two connectors, really. Think about the Tamiya connector. It's kind of a legacy design, right?
The white plastic rectangular one?
Yeah, that one. Small, round pins inside, often just crimped onto the wires. They tend to float a bit. Electrically, it's not great. High resistance.
How high are we talking?
Something like 1.3 ohms, which really limits it. Max continuous current is maybe 15 amps tops. And they're mechanically weak, too. Pins misalign, they lose tension.
Which makes the resistance even worse over time, leading to overheating.
Precisely. Now, contrast that with the Dean's connector, the T-plug.
That one feels much more solid, engineered for performance, I guess.
Absolutely. It's got that T-shaped housing, large, flat copper tabs that are sprung for really secure contact. And crucially, they're designed to be soldered, not crimped.
And the electrical specs.
Way better. Much lower resistance, think less than 0.4 ohms. It can handle serious current 60 amps continuous, bursts up to 75. It's in a different league.
Okay, so the Tamiya is like this old, almost misapplied connector design.
Some call it a Molex variant that just wasn't meant for high current RC use.
And putting that adapter in line basically means the Tamiya becomes the bottleneck. It just cancels out the benefits of having a good Dean's plug on your battery.
Exactly. It's the weakest link, and it drags everything down.
And this bottleneck isn't just theory, right? It has real effects when you're charging. Adding the adapter means more connection points, a bit more wire.
And each connection adds resistance. The adapter itself adds resistance. But the Tamiya connector part of it, that's the main culprit.
So higher total resistance in the circuit, what does that do? Ohm's law, right? V equals IR.
You got it. That higher resistance, especially at the Tamiya connection, causes a voltage drop. So the voltage actually reaching your battery terminals is lower than what the charger puts out. And it can be unstable too.
Lower unstable voltage. And where does that lost energy go?
Heat. Simple physics, joule heating. Power lost as heat is current squared times resistance. PICII. Since the Tamiya has the highest resistance point, that's where most of the heat builds up.
Ah, okay. That explains why you hear so many stories about those Tamiya plugs getting really hot during charging.
Dangerously hot sometimes. Melting plastic, potential short circuits. It happens. And all that energy wasted as heat means less energy going into your battery efficiently.
So charging takes longer?
Yep. Slower charging is a dead giveaway that energy is being wasted and potentially creating a hazard.
Okay, this is leading somewhere critical, I think. The smart charger. It's supposed to be smart, but this adapter sounds like it could really confuse it.
It absolutely can.
Yeah.
This is maybe the most insidious risk. Your smart charger, especially for NEAM packs, relies on detecting a very subtle voltage change to know when the battery is full.
That's the negative delta V or NDV.
Exactly. It's looking for a tiny voltage drop per cell, maybe 0.0005 volts. So for a 7.2 V pack, that's only about 0.03 volts total. It's a very faint signal.
And the adapter interferes.
Big time. The Tamiya connection, with its higher resistance and potential instability, creates what we call electrical noise, just erratic little voltage fluctuations.
And that noise drowns out the tiny NDV signal.
It masks it, yeah. The charger might completely miss that subtle peak and drop because the connection itself is causing its own voltage ups and downs.
So the charger, it just keeps charging. It doesn't know the battery is full.
Precisely. It misses the stop signal, so
Right.
it keeps pumping current into a battery that's already reached capacity. That's overcharging.
And overcharge in EHAM is bad news.
Very bad. It causes the battery to overheat internally. It damages the cells, reduces the overall capacity permanently, and drastically shortens the battery's lifespan.
What about backup safeties, like charge timers or temperature probes?
They can be compromised too. The adapter's resistance means the actual current flowing might be less than what the charger thinks it's delivering. So the timer might run too long, and the temperature sensor clipped to the outside might not detect the internal heat fast enough, especially if the charge rate is lower due to resistance.
Wow. Okay, so let's just lay out the spectrum of risks here. It's not just slow charging or maybe slightly reduced battery life.
No, it ranges from, performance degradation and chronic damage from repeated overcharging.
All the way to pretty severe safety hazards, right? Like the connector actually melting down, causing a short.
Yes. Or finding out the cheap adapter you bought was wired backwards from the factory, instant damage the moment you plug it in. And in the worst case, an overcharged, overheating battery could vent, rupture, maybe even catch fire.
But people use them all the time. Is it always that bad? What if you just need a quick charge?
Look, the risks are inherent in the design. If you find yourself in a situation where you absolutely must use one temporarily, well, harm reduction is key. Try to find a high-quality one.
What does that even mean for these
A
adapters?
thicker wire, maybe 18 gauge or even lower, like 16 or 14 AWG. Soldered connections, if you can tell. Robust construction, maybe from a brand you trust. But the most critical step,
Let me guess. Multimeter.
yes, always, always, always verify the polarity with a multimeter before you plug into anything expensive or flammable. Red to red, black to black. It takes seconds and can save you a lot of grief.
Okay. But that's just harm reduction. What's the real expert recommendation here? The best practice?
Simple. Get rid of the adapter. The safest, most efficient, most reliable solution is a one-time fix. Solder a proper Dean's connector directly onto your charger's output leads.
So modify the charger itself.
Exactly. It creates a single, solid, low-resistance connection point. Ensures accurate charging, maximum safety. If you're not comfortable soldering, your local hobby shop can almost certainly do it for you. Usually pretty cheap.
And if someone still insists on using an adapter, maybe while they wait to get the soldering done, any final precautions?
If you absolutely must, then manually lower the charge current on your charger, maybe half C rate or even less. Stay vigilant, never leave it charging unattended. Feel the connectors periodically. If they get warm, stop the charge immediately. And always charge in a safe place, like a LiPo bag or on a concrete surface, away from anything flammable. Treat it with extreme caution.
Right. So the takeaway really seems to be that while these adapters look like a simple fix, they introduce some pretty fundamental problems that undermine both performance and, crucially, safety when charging. Every connection counts.
It really does.
Which makes you think, what other seemingly simple connections, maybe in your tech, around the house, maybe even in daily routines, what other connections might be introducing hidden inefficiencies or even risks that maybe deserve a closer look, something to think about?